Welcome you all my lecture series of operating system. In this video we are going to see about what is the process synchronization and why we need the process synchronization in operating system environment. So already we know that the processes are two types. One is a individual process, other one is a cooperating process. So the individual process means that process can affect or affected, cannot affect and affected by another process is called an individual process. So the execution of individual process cannot affect the other process. Next is the cooperating process means the process can affect or affected by another process is called it as a cooperating process because they are sharing their data and logical address space. So they can affect the execution of one process can affect the execution of another process. So this is the cooperating process. So the process synchronization is required only for the cooperating process. For example, you have you know that what is the producer consumer problem. So in the producer consumer problem, they are shared the one shared memory. It is called as a buffer. So to allow the producer and consumer processes to run concurrently, we must have a shareable buffer of items that can be filled by the producer and consumed by the consumer. So this is the producer and consumer problem. So the buffer will reside in a region of memory that is shared by the producer and consumer. Here the shared region is a buffer. So the sharing region or sharing space, it may be a file or it may be a memory or it may be a CPU or it may be a printer. So that shareable region is shared by the two processes. So the producer can produce one item while the consumer is consuming that item. So the producer and consumer must be synchronized so that the consumer does not try to consume an item that has not yet been produced. So the producer consumer problem, the sharing device is the buffer. So the process synchronization is required only for the cooperating processes. So we have two kinds of buffer. One is an unbounded buffer, other one is a bounded buffer. So the bounded buffer means we have the fixed buffer size. In that the consumer must wait if the buffer is empty and the producer must wait if the buffer is full. For example, there is one example for why we need the process synchronization. Here we are using the counter variable is 0. That is variable is used for counting how many number of items in the buffer. So the counter is incremented every time when we add a new item in the buffer, and it could be decremented every time when you are consuming the item from the buffer. So the counter plus plus and counter minus minus. Suppose the value of the variable count is currently 5. The producer and consumer processes execute the statements counter plus plus and counter minus minus concurrently means the following execution of these two statements, the value of the variable counter may be a 4, 5 or 6. The only correct result through this is the counter should be equal to 5 because we are going to do the one increment and one decrement means our current value is 5. So one increment means 6, after decrement the value is 5. But the producer first do the operations means concurrent operation means the value is 4, 5, 6, 5 4 and 6. Next the consumer means the value is 4 5 6 5 and 4. So these are all the order of execution could be done in terms of a producer and consumer. So the counter plus plus, this is the statement. That instruction, micro instruction is equal to register is equal to counter. After the register plus 1, we are incrementing the value in the register, and that register value is stored in the counter. This machine language instruction is executed. That is, this assembly code instruction is the equivalent of that counter plus plus. So the order of execution, it is a concurrent one means the value is 5, 6, then 4. So the order of execution could not be synchronized when you are executing the producer and consumer concurrently. So we need the process synchronization. That means where several processes access and manipulate the same data concurrently means the outcome of the execution depends on the particular order in which the access takes place. So that condition is called as a race condition. So the race condition is occurred when concurrent access is done by the two processes concurrently. To overcome that race condition, we should do the process synchronization. Consider the system consisting of n processes. Each process has a segment of code called the critical section, in which the process may be changing the common variables, updating the table, writing a file in that critical section. So when one process is executing in the critical section, no other process could be entered into the critical section. That is, no two processes are executing in the critical section at the same time. So this critical section problem is to design a protocol that the processes can use to cooperate. For example, for every code we have the following structure of code of every process. We have a entry section, and after that we have the critical section, and from the execution of the critical section we have an exit section, and the remainder section is followed by the exit section. So each process must request the permission to enter its the critical section. So this section of code is implementing the request is the entry section. The entry section is the request section for every process to enter into the critical section. The critical section may be followed by an exit section. That remaining code is the remainder section. This is the structure of any critical section code in our program. Next is the solution to the critical section problem must be satisfied the following requirement, that is a mutual exclusion and progress and bounded waiting. So every solution we can find out that could be satisfied the following requirements as mutual exclusion, progress and bounding. In this video we know that why we need the process synchronization and what is the critical section is race condition is occur when you are not synchronize the two process. That means the two processes are executed parallelly means what is the output of value depends upon the order of execution. So next, why we need the process synchronization. The solution of the process synchronization should contain the following three requirements. Thank you.